Morning to this rather intriguingly titled session. Today's applied maths is tomorrow's pure maths. So this event is part of the KE Hub's program to try and ensure that we're promoting KE to the whole spectrum of mathematical scientists. Here, obviously, a bit of a dig at pure mathematicians, but we're aiming to help everybody to sort of own their responsibilities and to see the potential rewards, of course, most particularly of engaging in knowledge exchange. As some people have heard me say, I won't be able to actually stay for the session today because it's degree day here in Sheffield. So I'll be just going to wave off our contribution to the 2025 cohort of new mathematical sciences talent joining the real world today. But I'm going to leave you in the very capable hands of Chris Budd, who's Professor of Applied Maths at the University of Bath, if people don't know him already. Chris has curated this sort of fascinating collection of contributions for today's session. So, Chris, over to you.
Thank you very much, Eleanor. Well, welcome everyone, and it's a great pleasure to have you all here attending this event on today's applied maths is tomorrow's pure maths. So as Eleanor said, I'm at the University of Bath. Although I'm a Professor of Applied Maths, I have strong interests in all areas of math, pure maths, all the way over to applied and then beyond. So you're here as part of the Knowledge Exchange Hub. So I thought I'd kick off with just saying what math-based knowledge exchange is. And the key word is exchange. So knowledge exchange is a sharing of mathematical ideas, problems and data across the whole of the discipline to the mutual benefit of everyone. And the Knowledge Exchange Hub was set up recently to basically make this happen. Who's Knowledge Exchange for? Well, it's for everyone. It's for pure and applied mathematicians, statisticians, computational scientists, and so on. It's for industry. It's for society. A lot of our recent work in the Knowledge Exchange Hub is with the social scientists, and it's for policymakers and it's for government. But as I say, it's a sharing of ideas across this whole community. And today's event is really here to promote knowledge exchange and invite everyone to take part in this kind of experience of sharing. So why should we get involved in knowledge exchange at all? I think many of us, regardless of whether we think of ourselves as pure mathematicians or applied or engineers or whatever, want to see our work making a difference to the world. And knowledge exchange gives us a way of doing that. As we know, all universities nowadays, for the ref or whatever, want us to create impact. So that's knowledge exchange allows us to do that. It gives us the opportunity to earn income and grants, which can support PhD students or whatever. By the way, the Knowledge Exchange Hub can give you grants to do things, and Chris will talk a bit about that later on. Students love to see examples of maths in the real world, and so it gives us great teaching examples. Something I love doing with Knowledge Exchange, I find it gives me lots of new ideas. I meet lots of interesting people, and I learn from them. But I would say that the prime reason I do knowledge exchange, and I think it's a reason most mathematicians really like doing knowledge exchange, is it stimulates the creation of new mathematics. Okay, and I think that for me is the real driver. I've learned so much new mathematics over my career by doing knowledge exchange, and so have many. And then, of course, knowledge exchange is all of this and more. Here is what the internet says about this, and I think this quote really does summarize my own view. So today's applied maths is tomorrow's pure highlights the cyclical nature of maths, where looking at applications of maths leads directly to the development of new theoretical areas of study, and quite conversely, but absolutely wonderfully, theoretical advances, which of course have no practical application to start with, later find unexpected applications in real world problems. And it's this beautiful cyclical nature of maths which I really enjoy. and I think many of us do, and drives our wonderful subject forward. So, you know, abstract maths leads to applications, leads to more abstract maths, leads to applications, and so on and so on, in a wonderful cyclic way. Let's have just a couple of examples. We're going to get lots of great examples from our speakers today, but one of my favourites is Fourier analysis. So Fourier was studying heat flow in metal bars. You know, can't get much more applied than that. Wanted to solve the heat equation, which he basically derived, and realized that you could solve the heat equation by looking at combinations of sine waves. This still blows my mind. Sine waves are for triangles. What on earth it got to do with heat? But it did. And of course, having come up with that great idea, we then enter into the great world of studying the convergence and behavior of Fourier series, leading on to harmonic analysis, leading on to the Fourier transform, leading on to many, many wonderful areas of pure mathematical analysis. And then when you combine all that with complex variable theory and some ideas from networks and so on, you get to the fast Fourier transform, which in the 1960s led to the entire digital revolution. And my mobile phone here, we estimate, does about 1,000 or so, maybe even more Fourier transforms every second just to work. And we'll be hearing a bit more about this later on from Keith Briggs and some of the other pure mathematical ideas that have come out of looking at the FFT. So that's just a wonderful example in its own right. Another very timely example, Navier-Stokes equations, which, you know, used to describe fluid motion. No one still really knows whether they have solutions which are bounded for all time, for all initial data. And studying this is one of the millennium problems. It's a huge industry in pure analysis. And Google claims the solution is imminent using AI if you listen to the press, but it looks like exciting things are happening. So, you know, a very practical problem leads to huge mathematical endeavor. And I think that's just amazing. So just to say what we've got on for us today, we've divided the program into three. So session one, we're going to look at some historical perspectives, some fairly broad-reaching areas where looking at problems and applications have led on to really, really powerful areas of mathematical study, and then back again to applications. So that would be our first session. We'll then have a break. I strongly advise you to walk away from your screens and have a break for a few minutes. And then session two, we'll kind of come up to date and look at some pretty recent advances where new mathematical ideas are coming out of applications, starting with Gita looking at machine learning, which is just being explosive. Then we'll have another slightly longer break, and then we'll have a panel discussion. We've got some fantastic panelists, and we'd like the panel discussion to be prompted by questions from the audience. So if you have questions you'd like to pose to them, either put them in the chat for this session or send them to Gita on the KE Hub email, kehub@newton.ac.uk. That's the email you should have got for this event. And then we'll finish the session with the director of the KE Hub, Chris Brouard, telling you a bit more about it and talking about some of the opportunities that there are for knowledge exchange. So I will stop sharing now.